Hello and welcome to Unit 5 Post-Lab Notes. I'm here. I'm going to do these online. I was unfortunately able to make it to class, so we're going to do it like this. All right, we're going to move pretty quick through this. If you need to slow it down and pause it. I'm intentionally going to kind of go fairly quickly through this. And I would definitely do this lesson before you go ahead and try worksheet 1. We're going to go through quite a few example problems. So we started off last week with a lab, or earlier this week with a Newton's second law lab. All right, we had our carts. With a hanging mass, and we were trying to discover the relationship between acceleration and mass of the system. And what we found was a relationship that looked like this. And we would call that an inverse curve, or acceleration is proportional to the inverse of mass. So the more massive the system, the more mass, the less the acceleration we're seeing on that system. Okay, so we had that as inversely proportional. Part 2 of the lab, we took mass from the top of the cart and moved it to the hanging part of the mass of the system, and vice versa. Okay, and so what we were testing there was the relationship between the net force on our system and our acceleration. And we did this, we realized that increasing the net force, or the part that's hanging below the track on the hanging part, as we increase the force net, we also increase the acceleration of our system. Okay, so when we put those two together, we end up with a relationship that looks like this. All right, acceleration is equal to force net divided by our mass. Okay, more commonly you see this as rearranged to say net force equals M times A, or net force equals MA. Okay, and this is Newton's second law of motion. Basically, for the rest of this time, I'm going to give you quite a few example problems that show you how to use this in a variety of situations. Okay, let's go ahead and before we do that, and let's do a little bit of a unit analysis. All right, so according to this relationship, the unit for mass is kilograms. The unit for acceleration is meters per second squared. All right, and that happens to be a Newton. Okay, so there's our units, how we combine to become a Newton right there. This is very similar to our equation Fg equals M times 10 newtons per kilogram, like this. Again, notice this is kilograms times a Newton over kilograms, and it gets like this. And so a Newton is a kilogram meter per second squared. Just a little fun with units, just so you know what kind of units we're dealing with in this situation. Okay, the next thing we're going to be doing is I just want to do a real quick demo before we actually start the worksheet problems, okay, or the example problems that I have laid out for you. Okay, so what I'm going to show you is what happens on a bathroom scale. It's just a little bit strange, but it's going to help us understand part of these problems. So I'm going to go ahead and do a little rearranging here, and I'm going to show you, I have a demo set up here, like this. Okay, so let me arrange the video camera a little bit differently here. Bear with me. Okay, make it so you can see. What I want you to be able to see here, you can't see it real good here. There we go, let's see. Okay, we have a scale essentially right here, all right? And it looks a lot like a bathroom scale. Let me see if I can get both in the same shot here. Let me scoot it back just a touch. Oop, bear with me. Almost got it. This is great must-see TV right here. All right, now we can see the scale. Okay, and I also want us to see the screen, so I may have to do the screen in a different shot. I wish I could show that screen up there so you can see in real time what's happening here. Hang on, let me play with this screenshot just a little bit here. Almost got it. Let me see if that looks any better. No, the screen's still washed out.